Alright guys, I'm back with another video. I was just going to show y'all how to do this. You might learn a few things. You might actually find this somewhat useless, but some people might actually find it useful. So with one, it's not blended. I probably should have inverted that, but I didn't. And with zero, it's blended towards the... Basically, it's rotating the objects towards the surface normals. Yeah. Now, I will go ahead and point out that that doing this, it may conflict with some other nodes. If you do a transform point after this, then it might mess it up. Just letting you know ahead of time. So anyway, just be careful the order of operations that you place this in if you do decide to use it, or if you do find something to use it for. Making this is actually pretty simple. So you'll see here, I'm just sampling the landscape surface. I'm adding some random transforms right here to the scale. That's all I'm doing right here on the transforms. I'm projecting it onto those points onto the landscape. I'm just setting a branch so I can turn it on and off. And then I'm spawning it right here. Or I'm applying the surface normals if I decide to check that to true. So anyway, let's get started. So it's a fairly simple procedure here. I'm just going to go ahead and start a new folder, and we will, okay, first off, if you don't know how to do this, go into plugins and search for PCG and enable this. This is all you really need, but this other stuff, it adds other nodes and stuff to the graph that you might find useful. I haven't actually explored these yet, but I did find them using this right here in one of the epic videos that they did at the GCD or whatever. So anyway, GDC, I don't even remember the acronym. I'm bad with acronyms. So anyway, after you've enabled PCG, you'll see that you have a PCG thing here. You can just create a PCG graph. We'll call it PCG landscape normal blend. I'll just call it that. So I always like to save my stuff regularly because Unreal still is a bit unstable. Unreal Engine 5 is. So basically, you just want to sample the surface. So we'll get a surface sampler, and we want to get our landscape data, and this will give us our landscape. Now there are some nodes under here, but I won't recommend using any of these because I don't know what's going to change on the next version. If you move your cursor over here, it'll bring up a tooltip saying deprecated, please use custom pin to pass input into the graph. So as I said in the last video, you can add your own inputs under the input section, and you can add your own outputs under the input section too. I don't know why they call them both input. They'll probably change that later, but anyway, so you just have to select your type, the type of data that you need to pass through, and you set a name for it. That's pretty much it. That's how it works. So I would recommend doing that rather than using these if you do need to put this inside of another PCG graph where you have to pass stuff around. Don't use those inputs and don't use those outputs. You'll have problems with them. They are being deprecated. Well, the inputs are. I don't know about the output. I don't think so, but we'll see. Anyway, so you're just going to get this landscape data, and you're going to plug that into the surface because that's the surface you want to sample. So on the out, we're just going to do a transform points under spatial category, and that'll just allow us to up the scale here. I'm going to set the min and the max to 8 because the mesh that I'm using is quite small and I want to be able to see it from a distance, so it's easier for you guys to see it. You don't have to scale it up like that if you don't want to. Do it however you want, but that's how you transform the points. Yeah, so anyway, after you do that, we're going to do a projection. We want to project these points back onto the landscape because by default they are not constrained to the landscape because you might not want them to be, so that's why they didn't set it like that by default. The projection does project position and rotation by default. Sometimes you may not want to project rotation, but I think more times than not you're going to want to project this stuff, which is why it's default. So anyway, off of here we'll do a branch, and you can extend this right here, expand it, and it'll show these outputs here. And if you want to get the input for this outside of the graph, for example, if you're going to put this inside of a blueprint actor like this, then you're going to want to just type in property, and you'll see get actor property. That's the actor that this is inside of. That's why it says self. We don't need to change that. You could get it from a tagged actor if you needed to. That's another way you can get a property. But anyway, this is how we're going to do it. So you'll have to enter the same name that you named that variable inside of your blueprint. You'll have to copy and paste that name right here under the property name. That's basically all you have to do. So we're probably going to call ours enable landscape normal blend. Seems like the most appropriate name for it. And then we will spawn actors. No, my bad. We'll spawn static meshes. Spawn static mesh spawner, and it'll automatically convert this for you to points because by default that's spatial data. So that's the basics of it. We could go ahead and before we do this other, we'll go ahead and set up an actor. So let's do a blueprint actor. We'll select actor, and I'll call this BP landscape normal blending. I'll just call it blending because it's a little different than the one that I've already created. You'll open that up. You'll add a PCG component. So just go to search or go to add and type in PCG and it should pull up. Now we want to set right here, we want to set our graph to the one we made. This one right here, this PCG graph. We'll just select it in the content browser and then press the back button. And we'll save and compile that. Now we'll come back over here and we'll just hold down shift and right click this property. It'll copy that name for us. And then we'll create a new variable here, and I'll just Control V that name into here. And then I'm just going to make that public, instance editable, I should say. And I am going to leave it false as the default value. You can set yours to true as the default value if you want. That's up to you. Okay, so after we've done that, actually there's I think it's a bug. Maybe it's not a bug. I don't know. But I'm going to go ahead and do this. We're going to add a box collision because this will expand the bounds of this actor. And if you don't do this, for some reason, at least on mine, I don't know if it's a bug or not, but on mine it doesn't automatically draw that box. I thought it did, but apparently not. I'm just going to set mine to 8,000, something ridiculous, because I'm going to make mine big. And I'm just going to paste that into all the other fields. So you'll see I got this big box right here. This will make sure that our actor bounds, because our actor's bounds is only as big as the biggest object inside of our actor, and that's why I'm doing that. So anyway, we've set all that up. We've set this. You'll see that we don't get an error here. If you're getting an error, then you probably then the name here probably doesn't match the name here. So that's the reason why. So the next part is actually fairly easy. We're just going to do a apply scale to bounds thing here. And we're not actually going to use this. We're just going to press this browse to asset here, and it should bring you into this. If it doesn't bring you into this, go to settings and make sure show engine content is enabled. If it still isn't shown, actually I think this is under the C++. Let's see. Engine plugins. Okay. I don't think this is C++. No, it isn't. Okay, so checking show engine content should allow you to press that back button and it'll take you right to it. If not, you can enable show C++ classes if that's not already enabled. And then we're just going to drag this over into the new folder. Don't move it because you'll screw up your engine. Just copy it here. If you move it and then you try to use it later, it won't be there. And it might even cause Unreal to crash. So we're just going to press F2 here while this is selected, and we're going to rename this. So I am renaming this to we'll just call this BPC, BPG, whatever you want to call it. Let's see, what is this actor type? I forget. It's a PCG blueprint element. Okay, I'm going to call mine BPE, I guess. I don't really know what the proper naming convention is for this. Anyway, and then we'll just say landscape, normal, blend. And then we'll open this up in this node title right here. Just double click that. And we will type in blend to landscape normal. Or you can say blend rotation to landscape normal. Whatever you want to do. And then under the class defaults, this is under the transforms category, but you can make a custom one if you want. It's up to you. We'll just say custom O2 for me. And then I will enter the description here. Rotates object towards landscape normals. That's pretty much it. All we have to do there. Now on the last one that I did, I showed you guys how to do all the logic from right inside of here. Now that's actually kind of bad practice. I don't think you're supposed to do that. In our case, on that last one that we did, I had to, and the reason why is because inside of these point loop bodies, they have not exposed an index, and if I try to save this as a variable right here, and then I go into this point loop body over here, and I try to drag that variable out and use it, it just doesn't work. So I don't know why it doesn't work, but it just doesn't work. Probably has something to do with how it handles this in C++. I don't know. But anyway, so with that said, oh, you know what? I do actually know. The reason why is because this right here is not what you think. This right here is not looping through the points. This is looping through the inputs. So if you come over here to your class defaults, each one of these inputs right here will be, I think if I'm not mistaken, it'll be inside of this array. Custom inputs labels. Get inputs by pin label. Yeah. So that's the reason why. I was mistaken the last time, and I thought that this was looping through, but it doesn't. This loop body gets controlled in C++. So in order to expose the index of this point loop body, you would have to modify you would have to override their C++ class, and you'd have to modify it to have that option, but hopefully they add that in the future. Anyway, all we have to do is come in here and just hold down Alt and click on these right here. We don't need those. If your thing bugs out and starts doing this, then just let go of Alt. Because that's what I was doing. I was holding down Alt. So anyway, just uncheck those. We don't need those. We only need the transforms. You can also just press hide unconnected pins and it'll automatically do that for you. But we're going to move this off over here. We can also hide unconnected pins on this end. So what we're going to do is we are going to do a line trace off of each of these points. So I'm going to drag this off over here. And so let's go ahead and do this line trace. So we're going to drag off of this input pin. We're going to say line trace by channel. And that ought to work. And we just want to add to this location. On the Z, we want to add some number. You can guess, but you might end up having to increase this value later. I'm just going to put 2000 for mine. This is just how many centimeters above the point we're going to start tracing from. So we're going to start from above and trace down below it. And the reason why is because sometimes those points might be under the landscape. So if you don't start your trace from above it, then you'll miss that. And then we're going to do a subtract. Also, you might have to modify this later if you end up needing to ignore. You could make a custom trace channel, but there's videos on that. So if you need to trace through other objects, then you'll have to look up a video on that. I'm just trying to make this short. And we're going to also subtract 2000 on the Z, and that'll be the end trace. And then off of here, we're going to break the hit result. And we're going to select off of this select transform, because if this returns false, then we do not want to enter our calculations. Actually, let's just plug that back in like it was, and then because we're only modifying the rotation, actually we could modify the location as well to add an offset, but I've had mixed results with that using the normals. So we're just going to do the rotation. So we're going to get the impact normal, and we'll just, let's see, we're going to plug this in. Let's do another select rotator. And for the impact normal, we'll just plug that into A. And it'll automatically create a rotation in world coordinates based off of the direction that impact normal vector is pointing. And so we don't need to worry about converting it. It automatically converts it for us. And then we're going to plug in this return value right here. So if it hits something, it will choose the impact normal for the rotation of the object. And if if it doesn't hit anything, then it'll just choose the rotation it's already set to. And that's just a fail-safe. So actually we want to add one more thing here. I'll just show you how to do this. It's really not important, maybe for visualizing or testing, but really you just want this to be on or off. You don't want to blend between, because there's no real way to actually rotate it towards something without issues. But we can do a lerp off of this lerp rotator, and actually, yeah, we'll just keep it like that. I thought maybe turning this on or off would fix that to where it would rotate straight towards it, but it doesn't. I think it helps prevent issues with quaternion stuff. If I might tell you all about that later. It's a little hard for me to explain. I'm not real in the know when it comes to quaternion math. But basically, there's this term, and I can't think of it off the top of my head. I think it's called gimbal lock. Yeah. Gimbal lock, that might have something to do with gimbal lock, but I don't know. So anyway, we'll just plug B into there as well. And then the alpha, we'll just promote this to a variable, and we'll call this blend alpha. And I didn't do this on mine actually. Yeah, make sure you make this instance editable. But you could swap these, because if it's 1, then it'll be, let me see. Okay, yeah, let's do it the way I was doing it. Yeah, if it's 1, we want it to be rotated, but if not, then we want it to be the regular one. I did mine the opposite way because it made more sense, because you can go below negative, you can go below 0 and it'll rotate in the opposite direction. So you can do it the opposite way if you want. So anyway, it doesn't really matter if you check that or not. I didn't really see a difference when I did it on mine. So we will plug this. Oh, first we need to bring ours in. So if you right click and you go to Custom O2, oh, that's what I named mine, but whatever category you put yours under, go under that category and you'll find it right there. And then we're going to, oops, my bad. Yeah, we're going to plug this in right here. You could set this up to take in spatial data so that you don't have to convert to points, but I don't think it's really that big of a deal. I don't think it's going to have too much of a performance impact. A very negligible one. Oh, we want to be able to apply a rotation to... No, we don't need to apply a rotation. I had mine set up to do rotations, didn't I? I don't even know where my... it must be under the content. Here we go. Let's see. Yeah, I don't know. I thought I had... I was probably experimenting with mine. I got confused. Okay, yeah, that's pretty much it. So yeah, we'll come back over here in our blend alpha right here. We'll go ahead and do a get actor property off of this. And let's see, it's a blend alpha. So if we come back over to our blueprint, we'll create another node. This will be a float. You can make it a Boolean if you want. I don't know if that'll still work, but I think it's probably preferable that you keep the variable types the same. Otherwise, you'll probably have issues. We'll just say enable landscape normal blend. I don't know if alpha. I don't know if y'all can hear that beeping on and off. I hope not, but that's, I don't know. I've been having issues with my USB stuff lately. So just copy that, make it instance editable, and then come back over into your PCG graph and paste that property name and then plug it in. And then that should, no, it's not, that's not it. We need to go over here to our static mesh spawner and create an entry right here. And I downloaded, it's just some pillars I downloaded from Quixel Bridge right here. So you can do that. And I'm just going to add this into mine under static mesh. Just press the backspace button. And should be just about it. I'm going to go ahead and delete this one. And I'm going to drag this one out here. Oh, damn. Okay. So you can reduce your points if you want. I probably should have mentioned that. Let me, because I don't know what kind of computers some of you guys are running on. But you can come over here to your surface sample and you can, I think you increase this value. No, decrease it. Is it decrease? No, it's increase, I think. Oh, wait. I'm looking at it wrong. I think it's this right here. No? Okay, 0.01. I was going in the wrong direction, I think. I think this has something to do with it too. I think you can increase this to like something like that. That's just points per square meter, and then that's the extent of it. So anyway, the extent, I believe, is kind of like its bounds, in case you were wondering. I'm a little zoned out today, so anyway, I just wanted to get this out to you guys. But if I enable this, it works, but my scaling is getting messed up because we missed something. Let's go back in here. We need to open up, just double click that. It'll bring you back in here. We need to plug this scale back in. So just plug that scale back into the make transform because we don't want to modify the scale. And then come back over here and enable it, and you'll see that they should be rotated towards the surface normal. Now, depending on where your transform is, it may go through the landscape, but the transform of these is down here, and as you can see, it curves up exponentially on here. So it curves up like this. So since it's sampling right here, it's probably not going to be completely accurate. Anyway, I just wanted to show you guys how to do that. In case you were wondering, yes, you can do line traces. They do work, but you can't do them from this execute with context body. You have to do them from the loop. If you do them from the execute, you're going to have issues. I had serious issues that broke stuff. I didn't know what was going on. I thought I'd corrupted my project when I tried to do that. So don't try to do a line trace on the landscape from inside of here or on anything from inside of here. Do it from inside of your point loop bodies. And yeah, that's pretty much it, guys. I'll see you guys in the next video.